it is a data that this is the data you are adding this pattern. So when the receiver is going to be receive it, look that it is 0 0 and finding that 0 and 610. So he is going to be think that okay, this is the ending bits. Okay, so you can see that this pattern is similar to this. Okay, like same the byte stuffing you have seen, it is represented with the bits. So you can see that it is going to be understand that there is going to be a ending bit. So he is going to be not counted this. He's just going to be count that as a 0 0 is that the data byte. So that is why what is going to be the rules? It said that bit stuffing is the process of adding one extra zero whenever five consecutive one follow a zero in the data. Okay, so what it is doing? It's doing that if it is my pattern, starting pattern and ending pattern, or starting flag or ending flag. So what I have to do, I have having here six. So that's why I said that after five, if I counting that there are total number of five, one, two, three, four, five. Okay, so after that the five one I have added a zero. So one extra bit has been added here. Look that 1 2 3 4 5. Then we are going to be start from again. That is the 1 1 0 0. No problem. 1 1 0 0. Then here again we got 1 2 3 4 5, and after that zero. So that there are five one we are getting here consecutively. So that means again we are adding a zero. Okay, so this for that this 5 1 we are adding the zero, and then it is moving on 0 1 triple 0 0 1 triple 0. So this is how that the receiver can actually um I mean avoid that from that the ending flag. He'll not count that as a ending flag, because there are not 6 1 consecutively. Now we are having the 5 1 only. So that is what that when receiver has received this, and he is going to be received that the bits data bits correctly, and then he need to be unstuffed. So that means he is going to be remove this zero, adding this and this zero, so that he is getting the original data. Is it clear?
Sir,
Yes, sir.
Sir, repeat please.
Yeah, so
s-
what we said, that is the quite simple thing. We say that okay, this is a pattern we are having. Okay, what is that? Zero, sorry, this one, 0 and 6 1 0. Okay, so this is the flag we are going to be use here. That is actually this pattern, 0 6 1 0, and end pattern is going to be also 0 6 1 0. Okay, and this is my data. So if I am not adding these 0 and 0, okay, so we are sending that as it is that it has been sent and received by, now it is received by the receiver. So the receiver look that he is going to be take the flag, that is the 0 6 6 0. So now he is actually taking the data, and he finds that 1 2 3 4 5 6. So he got the 6 1, and then he got that the 0. I'm sorry, yeah, 0, right? One, 2 3 4, sorry, this is that the 7 bits, right? So 1 2 3 4 5 6. So if he getting that the pattern, that he is going to be confused. Okay, so actually this is going to be much clear, that if you're saying that this is that the data I'm having. So you can see that the pattern here we are having, that is 0 6 1 0. So now we are having here that this is my data. This is my data. If you're seeking that, this can be happen that in a pattern finds that 0 1 2 3 4 5 6. So in that case, and then it's 0. So it is actually matching with that the flag bits. So if it is matching, then that the receiver will understand that, oh, this is a ending flag. Okay, so he is going to be count only that 0 0 as a received data, and he is not going to be count the rest of the part. Understand or not?
Yes, sir.
Yes, sir.
So that is that is why that the rules has been given, as because that I am having the 6 1 before that, 0 and 6 1 0. So if that five consecutive one we am getting, if I'm getting in the data, immediately I'm going to be places 0. That is actually that is saying that the one extra 0, if you are getting that whenever five consecutive ones you are getting follows with the zeros, then you must need to be add a what bit stuffing. Okay, so that means what is happening, that what is going to be stuffed. Look that 1 2 3 4 5. So that the 5 1, then after that you have added a 0. 1 2 3 4 5. After that you have added 0. That next is coming 1 1 0. So you are writing that 1 1 0. Then you are getting again 0 1 2 3 4 5. Okay, so that means you have to add 0, and then you are going for that the rest of the bytes. So that is how actually you can avoid. Okay, that I mean, what you have to look after, that the flag you're giving as a pattern, that pattern should not be into that the data. And to break that, actually you have made the rule that you are going to be add an extra zero when you're getting that, after a zero when you're getting that the 5 ones. Understand or not?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, if the bit pattern, a given bit pattern is different, sir, then this bit stuffing style will be changed, sir.
Yeah, so that I mean, whatever that the data is, it forget about it, that how many ones are there. Okay, the rules is that, okay, you're finding a zero, and after that if you're getting 1 2 3 4 5 1, right, in the data, whatever, I
Yes,
mean,
sir.
101 can be there, no problem on there, but you are going to be count after 0 1 2 3 4 5. So you getting that 5 consecutive one, then you have to do the bit stuffing. Understand or not?
Yes, sir.
Yes, sir.
So this is the point, nothing else than that. So if you are finding that zero following with 5 ones, that means the next bit is going to be, you are going to be add an extra bit. So that I mean, there is no confusion with that the starting frame and the ending frame. Is it clear?
Yes, sir.
Sir,
So
Sir,
this is,
sir,
yeah, this is similar to the byte
sir,
stuffing. Yes.
here, sir, here, and 0001, sir, here is 000, sir. First 20 and last 20 is header and trailer.
I don't get you. What is the header and tailor again?
স্যার আপনি এখানে স্যার আমরা ওই যে ফার্স্টে 6টা 1 তারপর 0 স্যার কোশ্চেনে, তো ওখানে আবার আমরা যখন দুইটা অ্যাড করেছি, মানে দুই পাশে যে দুইটা দুইটা করে 0 এক্সট্রা দেওয়া আছে, ওই দুটো কি হেডার এন্ড ট্রেইলার?
No, that is not the data. Try to understand that I am having the 8 bits data, right? So you are talking about this part, isn't it or not? So you have to understand that this is your 8 bits and this is your actually the starting flag and ending flag. Do you understand that? The 8
Yes, sir.
bits is your starting flag and ending flag. This bit
Yes,
pattern
sir.
is that the indicating of the starting flag and ending flag. Is it clear now?
Yes, sir.
If it is not clear, then you can ask the more question, no problem on there.
স্যার রিসিভার সাইডে যখন হচ্ছে ডাটাগুলো রিসিভ হবে তখন 0 পাওয়ার পরে কনজিকিউটিভলি 5টা 1 থাকলে তারপরের 0টা রিমুভ করে নিবে।
You have to add, I mean, that is the sender side is going to be add that extra. After getting the 5 ones, he is going to be add 0. Okay, single bit 0.
স্যার ইন
That
দ্য
is the
রিসিভার
starting,
সাইড,
that is the starting. Yeah.
স্যার রিসিভার সাইডে যখন আমরা কনজিকিউটিভলি 5টা 1 পাবো তখন ওই 0টা রিমুভ করে ওই ডাটাটা কাউন্ট করবে।
Right, that is going to be unstuffed. Okay, to get the
Okay, sir.
original
Thank you,
data,
sir.
you have to unstuff.
স্যার এখানে তো 6টা 1 আছে, আমরা যদি এখানে যদি 5টা 1 থাকে তাহলে কি আমরা 4টা 1 এর পরে 0 দিব?
Now you are making me angry. What is the rule? Read that this point. The bit stuffing is the process of adding one extra zero whenever 5 1 consecutive. Whenever 5 consecutive ones follow a 0. Do you understand that? So why you are talking
sir,
about the
is this
code?
rule fixed?
Yes, this is going to be fixed for bit stuffing here. Okay.
Okay,
So
sir.
for example,
Yes, sir.
if I'm getting this I'm getting that, for example, that starting bit is my like that. Let me tell that, okay, the starting bit is my like that. So how many ones we are having here? That you have to count. Say that 1 2 3 4 5 6 7 8 9. So that on that time, if you want to use this pattern as a flag, then on that time, if you're getting consecutively 8 1, then you're going to be with the 0. Get my point or not?
Yes, sir.
So it is going to be depend on the pattern you are getting for the flags. Understand? There are the number of ones you are having. From that one number you are going to be less count. Okay, and then after that you are going to be given 0 bit stuffing. Is it clear or not?
Yes, sir.
So this is a, I mean, very simple thing that, I mean, you are having the 6 1 here in this pattern. You are having the 6 1 in between the 0 and 0. So that means you need to be make one minus. So that means you are having the 5 ones. So if you're getting the data consecutive 5 1, then you are going to be add an extra 0. That is going to be stuffing, bit stuffing. Understand or not? The receiver end, when you have received this, that time you have to unstuff that the 0 you have added, that the 0 is going to be what? Unstuffed. Okay, to get that the original data.
Okay, sir.
All right. Any other question here? How many students listening us? Only 1 or 2 people are talking. How about the others?
Sir, we are listening, sir.
Yeah,
So I
right.
think now it's clear, sir.
All right. All right. Thank you. So now you are going for that the flow control and error control. It says that these are the most two important features that we are having in the data link layer. Okay, so uh, the, the responsibility, right? These are the considered as the main responsibilities of the data link layer. That one is the flow control and another one is the error control. And what they are already we know. We know that when the sender is sending that the frames to that the receiver, so it's the sender should need to be know that how many uh, how how many frames the receiver will be able to receive at a time. Okay, so that should need to be, I mean, a mutual understanding that okay, how much byte at a time that how much frame that at a time the sender is going to be sent to the receiver. So the tennis ball example I have given to that in your class, I hope that you can remember.
Yes, sir.
Yes, sir.
Yeah, so that is the flow control. And that in case of the error control, what is happening, that you know that we said that one of the main goal of that the data link layer is that the sender node is sending a frame to the receiver, so the receiver should need to be ensured that he has received the frame error free. Okay, so if there is an error, he is going to be asked for retransmit that the frame. Okay, that the to the sender, he is going to be asked that okay, retransmit that the frame if there is an error. So this is going to be that, I mean, we are going to be studying now that the protocols. Now let's see how the data link layer can combine framing, flow control and error control to achieve the delivery of data from one node to the another. So that we are going to be now studying. So here the taxonomy of the protocols here we are having that has considered the noiseless channel and the noisy channel. So the noiseless channels means here that there is no congestion or no, I mean, the road is free. Okay, so you, when the road is free, you can actually reach from a node to the another node without facing any problem. So on that case, we are using that the two protocols, the simplest protocol and the stop and wait protocol. And for noisy channels, that I mean, it is going to be I mean, definitely there is going to be some noise, there is going to be some congestion. Okay, there are some problem, traffic load is going to be high. So on that time we are using that the different types of protocols, that is that the stop wait ARQ, go back and ARQ, and the selective repeat ARQ. So we are going to be study these 5 protocols from this part. So we are starting with the noiseless channels, and we are starting the discussions with the simplest protocol. So with the name, you can understand that, I mean, this is going to be very simple. What is happening is that the sender is going to be send the data. It's going to be create an event, and just he's going to be send a frame. And after a certain time that he's going to be create another event, and he's going to be send that the another frame, something like that. So that is actually shown into this example figure. So you can see that the sender is actually creating an event and sending the request for sending the frame, and receiver is receiving this. And after some time, he's sending that the another frame that is received by the receiver. And after some time, he's sending that the another frame. So this is what the sender is going to be send the frame to that the receiver, and he's not going to be expect here any type of acknowledgement, because that the channel is noiseless. Okay, so that is what it is the simplest protocol. Is it clear?
Yes, sir.
Yes, sir.
So here is nothing more to discuss. So now come to that the stop and wait protocol. So this is that the protocol that is actually for the flow control. Okay, so it wants to, even though that the channel is noiseless, but it wants to make sure that the receiver has received that the frame. So what he's going to be do, the sender is actually going to be send a frame, and he's going to be stop. After sending the frame, he's going to be stop and wait for what? The acknowledgement of that the frame he has sent. So that receiver is, after receiving the frame, he's sending the acknowledgement. So when that the acknowledgement has been arrived, so the sender actually confirmed that frame 1 has been received by the receiver. So he is going to be now send that the next frame, and again he is going to be stop after sending it, and he's going to be wait for what? The acknowledgement. So that when this is going to be arrived to the receiver is going to be given an acknowledgement when it is going to be arrived. So sender is going to be understand that okay, the second frame has been received. So this way, the third frame again he is going to be sent, and he's going to be stop and wait for that the acknowledgement. When acknowledgement comes, then fourth is going to be sent. Something like that. Is it clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
So it is telling that for sending a frame, the sender needs to be needs 2 events, and the receiver needs 1 event. Every time 2 and 1. So that means for the sending that the 2 frames, we are using the sender size. The 4 events are there. So it is written here. You can find that. Note that the sending node 2 frames in the protocol involves the sender is sender in 4 events and the receiver in 2 events. Is it clear?
স্যার এটা আরেকবার একটু যদি বলতেন স্যার।
So if you are sending a frame, that in the sender side you need the 2 event. One is for sending the request, you are stop and wait, and another is that you are receiving that the acknowledgement. So that is count as that the 2 events, okay? Because you are stop and waiting. You are stop and waiting, and your waiting is going to be when finished. Then upon receiving that the acknowledgement. Is it clear?
Yes,
Yes,
sir.
sir.
Here 2 and receiver side 1. So 2 frames, that means 4 events, and 2 events into the receiver side. Is it clear?
Yes, sir.
That's good. Okay, so yeah, so now here that we are moving forward from the noisy channels. So we say that although the stop and wait protocol gives an idea how to add the flow control to its predecessor, noiseless channels are non-existent. So here we are going to be used for noiseless channels the 3 protocol. One is that the stop and wait ARQ and go back and ARQ, and the selective repeat ARQ. So we are going to be discuss now the stop and wait automatic repeat request. What is happening here? It said that error correction in stop and wait ARQ is done by keeping a copy of the same frame and retransmitting of the frame when the timer expired. So what it does actually, that when he's sending that a frame to that the receiver, he's actually start a clock. Okay, so after sending, he is actually waiting. Actually, he set a time so that it is 5 seconds. For example, it's too much big time. Okay, but it's an example. So 5 seconds. So he's going to be wait for that the acknowledgement. Okay, so he's getting that the acknowledgement within 5 seconds. So that means he ensures that yes, frame has received by the receiver. So he's actually stopped that timeout. Okay, then he is going to be send the next frame, and again he's going to be start an event, and he's going to be start the clock. Okay, so now he is actually set the time 3, but within the 3 seconds the acknowledgement is not received, so that the timeout after 3 seconds. So he is going to be retransmit that the frame number 2. Do you understand that or not?
স্যার
Yes,
টাইমের
sir.
ভিতরে যদি না যায় তাহলে আবার কি সেটা সেন্ড করবে?
Right, exactly. He's going to be resent that the frame. So it is the example is coming into the next slide, so it is going to be more clear. So in stop and wait ARQ, we use the sequence number to the number of frames, so that the number of frames you're sending, say that three numbers you're sending, so it is going to be used that sequence number. So what is going to be the sequence number here? So he said that the sequence numbers are based on that the modulo 2 arithmetic. So the 2 sequence numbers are going to be represented with 0 and 1, are because that the sender's window size is going to be 1, receiver's window size is going to be 1. What does it mean? It means that sender is going to be send a frame. So that means sender is going to be able to send a single frame, and the single frame actually the receiver will be able to receive. So this is that we call that the window size, that okay, this is going to be that first window you are sending, one window you are sending, so that means he is going to be receive one window. So what is going to be the sequence number for them? So it said that for sending the frames, what is going to be the sequence number? It said that 0 and 1. So for example, that you want to send that the 3 frames, so it is going to be 0 1 0, something like that. Is it clear?
Yes, sir.
it's going to be more clear here if you're looking here. So you can see that this is what it's showing, that I mean this is that the frame number. So you can see that the sequence number is 0 1 0 1 0, so something like that. So now for example that you're sending the frame, so this is the byte, this is said the sequence in that the byte you are sending, and after receiving that the byte, so what is received, he has actually received that the sorry, he has actually sent that the one, this is the next frame to send SN, okay, and this is the starting ST first SF, okay. So this is that the one he has sent, and when it is that the one it has been received, so on that time he has received this, so what is that the acknowledgement he is going to be given. So this is the next byte, what is that the receiver side next, he is willing to receive that the next bit, so that is the 0. So he's going to be asked give the acknowledgement 0. So when it is going to be received by the sender, so the sender is going to be send this 0, and it is going to be counted as send, that is the send next, okay. So when it get that 0, so on that time it is going to be given that the acknowledgement 1, something like that. So it is going to be clear here. So if you're looking here, so look that what is happening here, let me figure of the figure. Okay, so here you are having that the one window you can send at a time. So you are having total 6 frames with the 6 sequence numbers, that 0 1 0 1 0 1. So now you are going to be saying that, for example, the first 0, this is the starting bit here. So you are sending the frame 0. Yes, of course, that even you have started with the clock, and when that the receiver has received that 0, so he is going to be give that the next sequence number that he actually would like to receive, that is 1. So he's giving the acknowledgement number 1 as a acknowledgement, so that this acknowledgement received here arrival, so that means that stop clock, so, the real time clock, time clock is going to be stopped. So now he knows that, I mean, the sender, I mean receiver has received that the 0 sequence window frame, I mean correctly. So now he is going to be send that the 1. So now he's sending that the 1 here. So the frame 1 he has sent, and the frame has been lost. So that the frame has been lost, that is not known by that the sender, as well as not known by the receiver. So what is going to be happen, so that the time you have selected, for example, 2 seconds, so that what is going to be, and after 2 seconds, within 2 seconds, that the sender has not received any acknowledgement, so he is actually counted it as a the receiver has not received that the window with the sequence number 1. So what he's going to be do, he's actually going to be restart the clock, and he's going to be resend it. Look that it say that frame 1 is resent. Frame 1 is resent. So that the frame has been received by the receiver. So this is that the 1 it has been received. So the next sequence number is 0. So he is actually going to be give the acknowledgement number 0. So he's with that actually he's telling to that him that I am expecting the next sequence number, window sequence number 0. So now he has received, so that the clock is stopped, and now that next byte he is going to be sent, that is actually the 0. So this is that the 0 he's sending and starting the clock, and he's sending now that the 0, the frame 0 has been sent. So now when it is received the 0, so it is window sequence number is 1, that's why acknowledgement number 1 he has sent, but the acknowledgement number has been solved, not, I mean, lost. So that means sender has not received it. So sender is waiting, and the time is timeout. So when it is timeout, on that time he understood that the receiver has not received that the frame that he is actually assuming. So what he's doing, he is actually sending the same frame, same window with the same sequence number, the 0. So he's sending the frame 0, resent, okay, resent, he has resent. So when that frame has been received by the receiver, so now the receiver is saying that, oh, I am waiting for that the number 1, but he is sending me that the number 0. So he understand that, oh, there is a this is a duplicate window that actually he has sent again. So he understood that receiver understood that the acknowledgement number who he was sent, that has not been received by the sender. So that's why what he does, he is actually repeating with that he is actually repeating that the acknowledgement, he's sending that the acknowledgement, so that actually the sender understood that, oh, that the receiver has not received my previous sequence number window. Is it clear?
Yes, sir.
Yes, sir.
Yeah. So this
Yes,
is
sir.
actually that way that actually the stop and wait ARQ for the noiseless channel works. So there is that I mean it should need to be ensured that actually the sender is sending the frames that is actually receiving correctly, and that is going to be done with that the acknowledgement. with that the acknowledgement, and with that the stopwatch, right? I mean, with that actually it is going to be know that actually sender has sent that the frame that has been received correctly or not. Okay, and also the receiver is also, I mean, active, right? That he is seeing that I have sent the acknowledgement one, but receiver does not know that the acknowledgement number lost. Is there even the sender does not know? So the sender is sending here that the again, because he did not get the acknowledgement for this zero number sequence window. So that's why he is actually timeout and restart, and he's sending that. But after receiving this, he's expecting the one, but he's seeing that it is sent the send bit number frame number is zero, the sequence number is zero. So he understand that, oh, this is I have already received, so this is a duplicate frame that has been sent by the sender, so it should need to be discarded. And that's why he's actually sending that an acknowledgement that no, I'm willing for that this one. So that's what actually that he understand that, oh, okay, so he's expecting this one, so that means he has received that the earlier window, so he is actually going to be sent that next frame as a frame number one, this one. Understand or not?
Yes, sir.
Yes, sir.
Any question here in the stop wait here queue? Any question? No, right?
No, sir.
All right, so thank you. So we are actually stopping our discussion today up to the 19th slide, so we are going to be start from 20 tomorrow. Okay.
Okay, sir.
Okay, sir.